So, chances are you're using tools like ChatGPT pretty regularly now. But have you ever stopped to wonder how they actually work? Today, we're diving deep into the engine of this AI revolution, large language models. We're going to look at the magic behind the machine, its incredible potential, and why the AI of tomorrow might make today's amazing tech look, well, ancient.
All right, let's just start with this quote because it's kind of wild. The CEO of OpenAI, Sam Altman, says that GPT-4, the model that feels like science fiction to most of us, sucks. I mean, how is that even possible? How can something so cutting edge already be yesterday's news to the person who built it? To get why he'd say that, we really need to look under the hood.
So let's peel back the curtain. Because if you want to understand the giant leap that's coming, you first have to get a handle on how the magic actually works right now. Okay, so the big picture term for all of this is generative AI. And the key word there is generative. This isn't AI that just analyzes data that already exists. This is AI that creates something totally new. It learns all the patterns and structures from a mind-boggling amount of information. We're talking the internet, books, you name it. And then it uses those patterns to generate brand new, original stuff. Now, within that huge world of generative AI, we're zeroing in on a specific type, the large language model, or LLM. You can think of these as the specialized brains inside the chat tools we all know and use. They're trained specifically on the patterns of human language. And when you see an image like this, you start to get a feel for the incredible complexity we're dealing with. It's called a neural network for a reason. It's a system that's literally designed to mimic a brain, with billions of connections that have been trained to spot patterns and context in language, letting it produce text that feels, well, surprisingly human.
So how did we get to this point? Well, the huge breakthrough happened back in 2017 with the invention of what's called the transformer architecture. And its secret sauce is a mechanism called self-attention. It's a clever way for the model to understand context. It looks at every word in a sentence and figures out how important each one is to the others. It's how it knows that the word bank means a place with money in one sentence and the side of a river in another. It's all about context.
Okay, I know a diagram like this can look super intimidating, so let's just ignore all the little boxes and focus on the main idea. A transformer basically does two things. First, the encoder part reads your prompt and tries to understand what you actually mean. It turns your words into math. Then, the decoder part takes that mathematical meaning and starts generating a new sentence word by word that logically follows your request. So it's a two-step dance. Understand, then generate.
So let's follow your question on its little journey, from your keyboard to the AI's response. First, your prompt gets chopped up into tiny pieces of words called tokens. Then, the machine turns those tokens into numbers, or embeddings, that capture their meaning. After that, the transformer model chews on all of that to understand the full context. And finally, it starts building an answer, one single token at a time, predicting the most likely next word until the thought is complete. Okay, so now that we have a feel for how they work, let's talk about what they can actually do. And, just as important, the very real risks that come attached to all this new power. I mean, the impact on business is already huge. Just think about it. An internal chatbot that instantly knows every single company policy, saving thousands of hours. Or an AI that can scan a 1,000-page report and pull out the 5 most important facts in, like, 10 seconds? From customer service to drafting complex legal documents, the benefit is clear. It's a massive productivity machine. But, and this is a really big but, all this power comes with serious peril. You have technical problems, like the model just making stuff up. We call them hallucinations. Or models repeating the biases they learn from their training data. Then you have bigger issues, like security risks, copyright questions, and the fact that these things use an enormous amount of energy. And maybe the weirdest risk is psychological. It's called the Elijah effect. Our tendency as humans to think the machine understands us, which can make us trust it way too much.
Here's a perfect and honestly pretty funny example of a hallucination. You ask a ridiculous question, and the model gives you a confident, well-structured, and completely nonsensical answer. The important thing to remember is, the AI doesn't know it's wrong. It's just following a pattern to its logical, and in this case, totally absurd conclusion.
This all gets to a really deep philosophical question, which is captured perfectly by this thought experiment called the Chinese room argument. The question is, does the machine actually understand what it's saying? Or is it just an incredibly sophisticated mimic manipulating symbols without any real comprehension? It's mastering the rules of grammar, the syntax, but does it understand the meaning, the semantics? Right now, the consensus is probably not. So, with that incredible power and those very real problems in mind, where do we go from here? Let's look ahead to the next generation and see how the industry is racing to make these things even better while hopefully fixing some of those big issues.
Which brings us right back to that first head-scratcher. If GPT-4 can already do so much, what could a model like GPT-5 possibly bring to the table that would justify calling today's version obsolete?
Well, Altman himself gave us the benchmark. He said to expect the same kind of leap we saw between GPT-3 and GPT-4. And if you remember that, it was a massive jump. It was the difference between a fun toy and a tool that could pass the bar exam. So he's predicting another leap of that same magnitude. That suggests much better reasoning, way more accuracy, and fewer of those flaws we just talked about.
So how do you make that happen? Well, there are two main ways they improve these models. You can think of it like this. Fine-tuning is like sending the AI to grad school to get a PhD in a very specific subject. It actually changes the model's brain. RAG, on the other hand, is more like giving the AI a library card and a live internet connection. The model itself doesn't change, but it can look up facts in real time before it answers you. This is a huge deal for cutting down on those hallucinations.
And you've got to know this is a full-on global race. It's not just a Silicon Valley story. While the US giants get a lot of the headlines, you have incredibly powerful and innovative models coming out of places all over the world. Mistral AI in France has been making huge waves, and you have key players from Spain all the way to the UAE who are pushing this technology forward. All of this intense competition, all this rapid progress, it's all pointing towards one single, ultimate, almost mythical goal that has been driving AI research for decades.
And that goal is what we call artificial general intelligence, or AGI. This is the holy grail. It's fundamentally different from the narrow AI we have today, which is great at specific tasks. AGI is the idea of a machine that has the flexible, adaptable intelligence of a person, something that can learn and reason about almost anything, just like we can.
So, how close are we? Well, just to bring us back down to earth for a second, researchers at Google DeepMind put together a scale to measure our progress toward AGI. On their 5-level scale, they say the best systems we have today are only at level 1, emerging. So in their view, we are at the very, very beginning of this journey.
And yet, on the other end of the spectrum, you have the famous futurist Ray Kurzweil, who's sticking by his prediction that we'll have human-level AI by 2029. So, who's right, the cautious researchers or the super-optimistic futurists? The truth is, whether it's 5 years or 50 years, the pace of this change is just staggering. And it leaves us with the ultimate question, which isn't really about the technology. It's about us. As we build these exponentially smarter machines, how will we, as a species, choose to use that power?